if we are going to convert between the mass of a given substance and how many particles are in that given sample of substance, we need to use that intermediate unit of the mole, because we can relate mass to the number of moles and also the number of particles to the number of moles that are present. And so to be able to convert between these, we need to use a couple of conversion factors. The conversion factor that allows us to convert between mass and moles, or grams and moles, is molar mass. A certain number of grams determined by taking the sum of the atomic masses in the formula per 1 mole of that substance. And to go between molecules and moles, we need to use Avogadro's number, because by definition there are 6.02 times 10 to the 23rd particles per 1 mole of that substance. And since these are both conversion factors, they are equivalent amounts both in numerator and denominator, we can invert them as needed depending on what units we're starting with and what units we are converting to. In this first example, we're starting with 20 grams of sodium hydroxide and we want to convert to moles. So we start by writing down our original amount, and to convert between grams and moles we need molar mass. And so we know that we're going to have a certain number of grams per 1 mole. Calculating the molar mass, sodium's atomic mass is 23.0, oxygen is 16.0, and hydrogen is 1.01. And again, these are values taken to 3 sig figs from a periodic table. When we add them up and round off properly using significant digits, we get 40.0 grams for the molar mass. Because we want the grams to cancel out, we put the 40.0 grams of NaOH on the bottom of the conversion factor and the 1 mole of sodium hydroxide on the top. The grams of NaOH will cancel out, and when we solve the resulting math problem that we have, we take 20 divided by 40, which is equivalent to 1/2. So we get 0.50, only 2 significant figures because of the original mass that we had to begin with. In this example, we are given 0.75 moles of sodium hydroxide and this time asked to solve for grams. So once again we are converting between mass and moles, so we're going to use molar mass as our conversion factor. This is the same substance as the previous example, so we know that it's 40 grams per mole. And in this case, since we are starting with moles, we want the 1 mole of NaOH to go on the bottom in the molar mass conversion factor so that the moles will cancel out and leave us with grams on top. And when we calculate, once again, we have only 2 sig figs to begin with, so our answer must be rounded to 2 significant figures. And in this case, that simply means that we have to make sure we put the decimal point after the 0 for a final answer of 30 grams sodium hydroxide. In this question, once again, we're dealing with sodium hydroxide, but now we're asked to determine how many formula units are in 3 moles of sodium hydroxide. Now, the term here being used as formula units because sodium hydroxide is an ionic substance, not molecular, so we're not asked how many molecules are there, but again, the word particle could be substituted. We're talking about individual pieces of this substance. So the conversion between moles and units is Avogadro's number. We want the moles to cancel out, so we're going to put the 1 mole NaOH on the bottom, Avogadro's number on top, and when we cancel the units and solve, correcting for proper scientific notation, you should get 1.81 times 10 to the 24th units sodium hydroxide. In this example, we are asked to determine how many units of sodium hydroxide would be present in a 35.0 gram sample of sodium hydroxide. So we begin with the given amount of 35.0 grams, and because we are going from grams to the individual units, we can't go directly because not all formula units have the same mass. It's dependent upon the individual substance. So we have to first convert from grams into moles and then from moles into formula units. So the first conversion to go from grams to moles will involve the molar mass of sodium hydroxide, which is the 40 grams per 1 mole. We want the grams to cancel, so that grams need to go on the bottom and the 1 mole on top. Grams of NaOH will cancel. This gets our quantity into the units of moles, and now we need to go up the other side of the diagram, which is moles to molecules, and or moles to units rather, and that is related by Avogadro's number. To get the units to cancel out properly, that means we need to put the 1 mole of NaOH on the bottom and the formula units on top. Canceling all those units out gets our units to what they need to be, formula units, and solving the math at this point, 35 times the 6.02 times 10 to the 23rd power divided by the 40 grams, you should come up with a final answer of 5.27 times 10 to the 23rd, and the units would be formula units of sodium hydroxide.